Okay, so now what we're going to do is put everything together, right? You'll notice in this chapter, in this section, we're still adding and subtracting fractions, but we're not starting with a common denominator, right? And so that adds up to the complexity. We learned how to find an LCD, and then we have to review how to build an equivalent equation, or excuse me, an equivalent fraction. And it's usually multiplying by some form of 1, right? Top and bottom by the same thing. So let's just kind of go back and look at some maybe easier examples, and we'll slowly build up to some tougher ones. So in this first one, right, I think just by inspection, you guys know the LCD is 12, right? So there's our LCD, and then I need to build an equivalent fraction. So the way we do that is by multiplying the top and bottom by 4, and that gives us 8/12. So when you say 2/3, that has the same picture, the same meaning as 8 over 12. If you take 2 and divide by 3 on your calculator, that's the same thing as taking 8 divided by 12 on your calculator. So these are basically two ways to say the same thing, but what's nice about the second way is it has the denominator I need as opposed to that one. What about 1/4? Well, what I need to multiply that one by is 3 over 3. So that builds 3/12. And again, same reasoning. You say 1/4, you build a picture for 1/4. That's the same thing as 3/12. But what's nice is this now has the same denominator, and I can perform the subtraction that's needed. We do that by keeping the denominator, subtracting my numerators, and in this case we get 5 over 12. So again, yes, I want to see that step. I've been begging you guys. I've been taking away things from you for the last few weeks. Some of you got a little upset at me, but the build-up is to this point here in Chapter 6. I knew it was ahead, and it's needed. You have to understand that that's there because we're going to be using it for a lot of different things. So for the next one, I think in the last video we found that the LCD was 60, but just again, 12 is 3 times 2 times 2. 30 was 5 times 3 times 2. And when we build that LCD, we recognize the only thing that Dad was missing was the 5, giving us the 60. So what do I multiply 12 to get 60? Well, it's 5. What do I multiply 32 to get 60? Well, it's 2. This builds the equivalent fraction 35 over 60, and this builds the equivalent fraction 22 over 60. I have the same denominator, so I can add my numerators, and it looks like we get 57 over 60 there, and that's the result of that addition. So we're good to go. Okay, in the next example, we already did some work, but just looking ahead, right, the first fraction, 6x squared y, is 2, 3x, x, and y. 9xy squared is 3, 3x, and y, y. And so when we piece together the LCD, we need a 2, a 3, an x, and a y. This guy will want to contribute an extra 3, right? This guy will also want to contribute an extra y. So we have 18, x squared, y squared is our LCD. So coming back over here, what's the missing factor? Well, to get 18, I need to multiply by 3, and to get another y, I need 3y. Whatever we do to the bottom, we do to the top. There's your balancing act. So I've multiplied the same thing to both sides. Minus, well, over here what we need, right, to get 18, I need a 2, and to get another x, I need x. So 2x is what I need top and bottom. So this gives us 12y all over 18x squared, y squared, and we're going to subtract, what is that going to be, 10x all over 18x squared, y squared. I have the same denominator, so I'll keep it, and I will subtract my numerators. All right, so 12y minus 10x. So now that the subtraction's done, the next move is to simplify. And then be very careful, right? I know y and y, they're the same, but y up here is being used in subtraction, so it's a term. Down here, the y is a factor because it's involved in a product. We only divide out common factors, not terms. So what we need to do is factor the top and factor the bottom. If we factor the top, I think the only thing that's common up there is a 2, and what's left is 6y minus 5x. and this is all over 18x squared y squared. 2 and 18 share a common factor, right? And it goes in 9 times. So I imagine the answer in the back of the book will be that guy right there. 6y minus 5x all over 9x squared y squared. And again, fight the urge to divide out those x's and y's, because right now up the numerator these are terms, and down to the denominator these are factors. You only divide out common factors like I did here, right? 2 and 18, right, are involved in products. They both share a common factor of 2. 2 goes in itself once, goes into 18 9 times. So we are left with just a 9. Okay, next one. This was a unique feature. The LCD was basically the 2 denominators I currently have. So building an LCD, this guy I would need to multiply the bottom by b minus 1. To be in balance, I do the top by b minus 1. For the next fraction, I need to multiply the bottom by b plus 1, which means I need to do the top by b plus 1. So here's what we get. We get b times b minus 1 all over our LCD plus 3 times b plus 1 all over our LCD. Now be very careful here, right? Because the intent is to add. And I have the same denominator to perform that addition. One of the most common mistakes students will do is they'll see the b minus 1 and the b minus 1 are common here, and they'll want to divide it out. So the good news is it's okay to divide it out because they are factors, but the bad news is you end up right where we started. And I can literally see students going around in a circle and busting their pencils and getting upset because they keep doing the right thing, and then they go back by dividing out. Don't divide out. The intent is to add. I have a common denominator, so the idea is we keep that denominator and we add up our 2 numerators. Okay? Now again, a common mistake is that b minus 1 and that b minus 1, students start to divide them out. Don't do that. That addition right there screws everything up, right? Because this b minus 1 is part of a term, and this b minus 1 is a factor. They're not common factors. So what we have to do is perform the addition upstairs. So we do that by distributing. We get b squared minus b plus b 3b plus 3 all over b plus 1 and b minus 1. And if we combine like terms, we get a b squared plus 2b plus 3 all over a b plus 1 and a b minus 1. So the good news is, let me bring this up a little bit, I noticed it's off. The good news is we finally added, right? The intent was to add. I found the LCD, played my equivalent fraction trick, did the addition, right? And so now the question is this final answer in lowest terms? I only know that if I factor. Well, the bottom's already factored for us, so let me leave it that way. And the top, if we factor it, I believe again it's going to be that combination right there. All right. First, oops. Actually, I don't think it factors. I don't think, yeah, because 3 is 3 and 1. UACers are going to shine here, right? Because there's nothing I can multiply up to 3 to get 2. So yeah, so that means since that top doesn't factor, it's prime, we're done. All right, so b squared plus 2b plus 3 doesn't factor. There's no common factors, so we're all finished. So whew, good news. Otherwise, we would have factored and divided out a common factor. So there you go. So that's how we're going to add and subtract. Of course, they're going to get much more difficult. The idea is use our trick to find the LCD, play the equivalent fraction game, add, and then simplify if needed. We had to do it here. We didn't need to do it there. So more examples, more complex examples coming, so make sure you're paying attention.